Let's talk about permutation and probability from lesson 21 of Algebra 2b. So, let's start with talking about permutation. What is permutation? It tells you the number of ways something can occur or the number of ways you can order something. So for example, look at this notation. We have NP sub R. Although it doesn't say this in your course, I like to refer to this as choose. And I'll tell you what I mean by that. I mean that I have n things and I want to choose r of them. So let's say I had 10 friends and I had 3 extra tickets to take to a concert, and I need to choose 3 friends to take with me. So I have 10 friends and I'm going to choose 3 of them. Or shorthand would be 10 choose 3. That situation is modeled here, where n equals 10, my number of friends, and r equals the number of friends I'm taking to the concert, 3. So if I wanted to know how many different combinations, how many different ways I could pick 3 friends to go with me, this is the number. Now in permutation, order matters. Which means, let's say we have the 4 seats at our concert. If I take friend number 1, friend number 2, friend number 3, and this is my seat, then I'm saying this would be different than if I had my seat here and took number 2, number 1, number 3 like this. So notice that the seats are different. So not only the 3 friends, but it includes the 3 seating arrangements. So with permutation, order matters. So if I wanted to solve this, I would take n factorial, so n is 10, my number of friends, over n minus r factorial. Remember, factorial means to take the product of the integer and every whole number below it between 1 and the number and multiply them. So for example, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So it's the product of the number times every whole number or every natural number below it, right? So we don't include 0. We don't multiply by 0. So if I wanted to simplify this, I would get 10 times 9 times, right, all the way down. But notice, I can cancel out some factors. So I could have 10 times 9 times 8 times 7 times 6 all the way down over 10 minus 7, or minus 3 is 7, so I've got 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Notice now I can cancel out numbers. So I can cancel out my 1s, my 2s, my 3s, my 4s, my 5s, my 6s, and my 7s. And I'm just left with 10 times 9 times 8, or 10 times 72, which is 720. Okay, so again, one way to read this notation is to think of having n objects and the number of ways you could choose r of them where order matters. Probability, or theoretical probability, is how likely an event will occur. And we find it without using data, meaning without knowing trials that have happened. So theoretical probability will always be the number of ways an event can occur over the total number of possible outcomes. So let's say we want to roll a 5. So if I have a die that has a 1, a 2, a 3, a 4, a 5, and a 6 on it, and I roll it, how many different ways can I roll a 5? Well, there's only one. I have to roll 5, right? So there's only one way I can get what I want. The total number of outcomes would be all of the possible rolls that could happen, and there are 6 of them. So I have a 1 in 6 chance of getting what I want, of rolling that 5. So again, theoretical probability, number of ways what we want can occur over total number of things that could happen. So we're going to practice with both of them. And you'll notice in these examples that I'm not going to say this is a permutation example, this is a probability example. I've mixed them up because it's important to be able to tell which one you're dealing with when you're faced with a situation in life, or maybe more relevant, a situation on a test. They're not going to tell you, oh, notice that this is permutation, notice that this is probability. So we'll practice that now. Okay. So there are 8 people on a swimming team, and the coach needs to choose, keyword, 4 swimmers and the order in which they will swim at the next meet. And how many different ways can the order be chosen? So key things here, they mention a choice and they mention order. This should tell you that we are dealing with permutation. Probability deals with, well, no order, probably doesn't have order, deals with, it'll usually say what's the probability, what are the odds, what's the likelihood. These are all words that will let you know that you're dealing with probability, and order doesn't matter. But today, or for this example, we've got permutation. So, I've got 8 swimmers. So let me draw my 8 swimmers, and I want to choose 4 of them. So I'm saying of my 8 swimmers, how many different ways, if each one of them is a unique person, let's see, that's 6 swimmers, how many ways can I choose 4 of them? So for example, and notice that even after I choose 4, if I choose these 4, not only do I choose them, I can order these 4 in many different ways, right? I could have 1, 2, 3, 4, 1, 2, 3, 4, 2, 4, 3, 1, right? And so on. Many combinations that way as well. So we're going to take out our handy dandy choose formula, or that NP sub r, and it equals n factorial over the quantity of n minus r factorial. So in this case, remember that n is the number of things total, and r is the number we are choosing. So we're picking from n and we're selecting r many. Okay, so in this case I have 8 swimmers, so 8 is n because that's my total, and I'm choosing 4 of them. So I get 8 factorial over 8 minus 4 factorial. This simplifies to 8 factorial over 8 minus 4 is 4. I get 4 factorial. Now, a cool thing about factorials, notice that 8 is actually equal to 8 times 7 times 6 times 5 times 4 factorial. 8 is equal to 8 times 7 times 6 times 5 times 4 factorial. How do I know that? Well, let me find somewhere to write here. Because I know that 8 factorial equals 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you look at this piece, 4 times 3 times 2 times 1, that's 4 factorial. So rather than having to waste all that paper and time writing the full thing out, notice these little shortcuts. So I'm going to write this as 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. So obviously my 4 factorials cancel out, and I'm left with 8 times 7 times 6 times 5. 8 times 7, let's see, that'd be 56 times 30. 56 times 30 is, what would that be, 1680. So there are 1,680 orders, or ways, that this coach can choose 4 swimmers and put them in a particular order for this swim meet. Let's do another example. So that was permutation. Let's see what we get here. A felt pouch contains 4 red marbles. Let's draw 4 red marbles, 5 blue, and 1 green, all the same size. when they say all the same size, they're just pointing out that they are, it's an even chance of drawing any marble. If Steve pulls a marble from the pouch, what is the probability that it will be red? Okay, so since they're the same size, that gives us an even probability, but notice that there are more red and more blue and not that many green. Meaning, if you had to guess, if I told you, okay, I've got 5 blue ones in there, 4 red and 1 green, you'd probably guess that you were going to draw a blue marble, right? Or a red. Very unlikely that you'll draw a green. We want to know, and they specifically say, the probability that we'll draw a red marble. So remember, probability is the number of ways it, whatever situation, so the number of ways it can happen. In this case, it is pulling a red marble, divided by the number of ways, or the number of ways, or number of outcomes total. Let's say that, number of outcomes total. So just the number of anything that can happen. So the number of ways I can draw a red marble, well, there are 4 of them, so I could draw any one of 4 red marbles. My total number of possibilities are 10 because I have 10 marbles, right? I have 4 red plus 5 blue plus 1 green, so I have 10 total. So remember, denominator is number of ways that our desired outcome, so our desire is to pull red, number of ways the desired outcome can happen over total number of outcomes, so 10 different outcomes for 10 different marbles. We simplify. 4 over 10, we can divide each of those by 2, which would be 2/5. So there's a 2 in 5, or 40%, or 0.40 chance of red. Now, you'll have to pay attention to the format, the answer format that they ask you for in your course player, whether they ask for the percentage, a fraction, or a decimal. Okay, let's practice again. There are 12 balloons in a bag. Let's get our marker out here. And we've got red, green, blue, and yellow, 3 each. And we want to know the probability that I pick 3 and all 3 are green. Okay. What's the probability that I pick 3 and all 3 are green? So this is going to be a compound event because we're not just picking 1, we're picking out 3. Okay, and I just realized that this is kind of poorly worded, but again, what we're trying to say that is if I draw 3 out of the bag without putting them back, so I draw a balloon, I draw another balloon, I draw another balloon, what are the chances that the 3 that I have in my hand are green? So we'll take this one step at a time. So I know I'm going to draw the first time, so first draw, I'm going to draw a second time, and then I'll draw a third time, and we'll consider each of these separately. So the first time I draw a balloon, what's the likelihood that if this is what's in the bag, what I get is green? Well, there are 3 greens, right? So 3, which is, remember, number of ways it can happen, number of ways that we can draw green on our first try, divided by total outcomes. So there are 3 ways I can draw green out of 12 total balloons, and we'll simplify that to 1/4. That's great. Let's look at this again. So that was our first drawing. So what does the bag look like on our second drawing? Well, I've already drawn one of these green balloons, right? I've already drawn one of those green balloons. So this is what my bag looks like now. So, in how many ways can I draw a green balloon? Well, now there's only 2 left, so there's only 2 ways I can draw it. And notice that the total number of balloons is now also reduced to 11. Okay, so on my second draw, I've already taken a balloon out. So there's 2 opportunities left out of the total 11. What about my third draw? So on my third draw, I've taken out one balloon on the first draw, now I've taken out another green on the second draw. So this is what my bag looks like now. Now there's only one green balloon I can pick from, and how many are left? 10 balloons. So you can see how we separated that for each situation, and we had to kind of reevaluate what our total outcomes were each time. Okay, so we didn't have 12 balloons in the bag each time. Each time the number in the bag decreased by 1. Now, to find the probability of this and this and this happening, we multiply. So we take 3, or we'll call it 1/4, times 2 over 11 times 1 over 10. The probability of this and this and this happening. Let's simplify. So I'm going to simplify this 2 with this 10. And I get 1 over, what would that be? So I'd get 44, 220. So there's a 1 in 220 shot of pulling 3 balloons, 3 green balloons in a row. So take a moment to consider that. Okay, summarizing it one more time. We separated each of our drawings into a different situation, and then we wanted to know the probability of all 3 situations happening. So we multiplied the 3 probabilities together to get 1 in 220. Okay, in a dog show there will be a gold, a silver, and a bronze medal awarded. There are 5 finalists. And how many different ways can the 3 medals be awarded? Alright, so picture our podium here. We've got first place, second place, and third place. And we want to know how many different ways can we pick out of 5 dogs. And no, I won't draw 5 dogs, that'll take too long. How many different ways of my 5 dogs can I select a first, second, and third choice winner? So in how many different ways should be a clue that we are dealing with permutation. In permutation, remember, order matters. Okay, so I have 5 dogs and I'm choosing 3 of them. So 5 choose 3. If you remember our formula, n factorial n minus r factorial. So this is equal to n being the number of dogs we have, so 5 factorial over, I'm going to choose 3 of them, so r is 3. So 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial. And bringing it down here, 5 factorial over 2 factorial. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. I cancel out my 1s, I cancel out my 2s. I'm left with 5 times 4 times 3. And I get what? Let's see. 5 times 4 is 20. 20 times 3 is 60. So there are 60 different ways I can select 3 dogs for this podium for first, second, and third place. Again, here's our formula for choice, where n is the total number we have and r is the number that we're choosing. N is the number we're choosing from, r is the number that we're choosing. Alright, let's do one last practice. Let's say each student receives a 5-digit locker combination. What's the probability, so they tell us, we're looking for probability, of receiving a combination with all odd digits? Okay, so there are 5 digits to this locker combination. So that means we've got our first digit that we're going to have to figure out the probability that the first digit will be odd, the second, the third, the fourth, and the fifth. Notice that these are all independent of one another. By independent, I mean that whether or not the first digit is odd doesn't make it more or less likely that the second is odd. Whether the second is odd doesn't make it more or less likely that the third is odd, and so on and so forth. So the outcomes of any one of these doesn't affect the outcomes of the others. So, what is the probability just that this first digit will be odd? Remember that the digits here include 0 on a locker combination, so our choices are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our odd choices are 1, 3, 5, 7, and 9. That's 5 out of 10 possibilities, right? Because we have 1, 2, 3, 4, 5 numbers that are not odd. So out of 10 total numbers, there are 5 that are odd, so we have a 1 in 2 chance of drawing an odd number. So the likelihood is a 1 in 2 chance that the first digit will be odd. What about the second digit? Well, if these are independent, then the second digit would have the same odds, right? It's still a 1 in 2 chance of whether this will be an odd or even number. It's the same thing for the third digit, the fourth digit, and the fifth digit. Each one of these has a 50-50 chance of being an odd digit. However, the probability that they are all odd, the probability that all of these digits will be odd, is found by, so if I call this, let's use some notation here. So if I call this event A, probability that the first digit is odd, event B, event C, event D, and event E, my notation would be the probability of A is 1/2, the probability of event B is 1/2, the probability of event C is 1/2, and so on. The probability of A and B and C and D and E, this little upside down U means and. The probability of all 5 of these things happening is the probability of A times the probability of B times the probability of C times the probability of D times the probability of E. Or in other words, 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So, I've got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have a 1 in 32 shot of getting a locker combination where all of the digits are odd. Okay? Now, hopefully this was not the first time you saw this notation. Remember, these videos are not meant to be substitutions for your lessons. They're just meant to be additional practice. So if that was the first time you saw this, it means you probably need to go back and take more thorough notes on the lesson. Of course, let me know if you have any questions. And remember to be careful when figuring out if you are dealing with a permutation problem or a probability problem or a bit of both.